Hi, this is Mrs. Kidman, and in this video today, we are going to cover how to solve from factored form. So basically what we're talking about here is we, in the previous videos, have been talking about how we multiply polynomials. So we've had these polynomials here that have looked like x plus 4 times x plus 3, and we've used one of our three methods, whether it's the FOIL method, the distributing method, or the matrix method, to multiply these. And as we multiply them, what we do is we end up getting x squared plus 4x plus 3x plus 12, and then that simplifies down into this expression right here. So when we're talking about solving from factored form, this right here is called standard form. And remember, our standard form is when it is written, standard form is when we have a problem here and our expression is written from the highest degree to the lowest degree, from left to right. That's standard form. When we're talking about factored form means that I've broken it apart, and instead of multiplying it together like I do with this FOIL method, I want to leave it as my separate pieces. So factored form is referring to this form right here, where we have it broken down into the factors of this polynomial, or those two parts. And those are kind of what we're focusing on today. So when we're talking about solving from that factored form, we're talking about solving what this is going to be. Now, in factored form here, when we discuss what it means to solve it, we are solving it for when it equals 0. So we're looking at situations like this, where I have x minus 1 plus 2 equals 0, x minus 4 plus 5 equals 0. Notice how all of these are equal to 0. When we're solving these factored form, the polynomials in factored form, we want to figure out what does it mean when it equals 0, what x values work when it equals 0. And the reason why this is so important is when we're in that standard form, what we end up graphing is actually something called a parabola. And a parabola just looks kind of like this. Okay, this is just the form x squared. And they will shift around, and we'll talk about that more in chapter 3 and chapter 4. But we're looking here at this parabola. Now, when we're talking about figuring out what the solution is or solving them, we're trying to figure out what x values can I put in here so that this statement is true. And what that does is as I graph these, what I end up looking at is I see this parabola and it crosses at these 2 points. And these x values here are our solutions to our graph. So we graph it in that standard form, but these right here tell us where it crosses that x-axis. So we want to find those solutions. Now, when we do that, what we are going to do is we are actually going to use a property here. And this property is called the zero product property. And basically what the zero product property says is that if I'm multiplying two numbers, a and b, whatever they are, remember variables are numbers too. Along with this, it applies to polynomials. So if I'm multiplying two things, and the multiplication or the product of those two things equals 0, then either this one has to equal 0 or this one has to equal 0. Okay, because remember, any number times 0 is 0. So using the zero product property, we are going to solve these products of these factored forms and figure out what happens. So let's take a look at this first one. So here, notice I am multiplying two polynomials. I have a monomial times a binomial. Now I want them to equal to 0. So these two polynomials that I'm multiplying, one of those two polynomials has to equal 0 for the full product to equal 0. I don't know which one, so I'm going to look at what happens when each of them equals 0. So in this first case, I have 2x equals 0. That's my first polynomial that's equal to 0. Now I can divide by 2 on both sides, and I can get that x equals 0. So if I put in 0 here, it's going to work. And we can check that, right? 2 times 0 times 0 minus 4, does that equal 0? Well, 2 times 0 is 0 times negative 4. Does that equal 0? Well, of course, 0 times negative 4 is 0. So that one works, right? Now let's take a look at this other one here. X minus 4 equals 0. We can solve that, and I get x equals 4. Now let's check if that one works. So as we check if that one works, I have 2 times 4 times 4 minus 4. I want to know, does that equal 0? Well, 2 times 4 is 8 times 4 minus 4 is 0. Does that equal 0? Well, any number times 0 is 0. So that works. So these two things right here are the two solutions to our equation. This is what I get when I try to solve those. I get x equals 0 as well as x equals 4. Those are my two solutions. So when we talk about solving these, we are talking about finding our two solutions here. Now let's do the same thing over here with this polynomial. So in this case, I'm finding the product of two polynomials, but I have two binomials. I have x plus 3 and x minus 9. So as I find the solution to these, because it equals 0, I know either this one has to equal 0 or this one does. So let's find the two solutions. We have when x minus 3 equals 0, and we have when x minus 9 equals 0. Now I can just add 3 to both sides here, and I get x equals 3, and I get x equals 9 when I add 9 to both sides. So notice how this is kind of like the conjugate pair. If I have an x minus 3, the solution to that is going to be a positive 3. If I have a plus 3 in there, it's going to be a negative 3. We're just solving that solution and setting them equal to 0. And we can do this regardless of what we have. Here are some more examples if you want to try them on your own. What I'm going to do is I want you to pause the video. I want you to try example number 3 here, all on your own. Once you've completed example number 3, unpause the video and check to see if your solution matches mine. Hopefully you took a second to pause the video and try that one on your own. I got z equals 4 and z equals 6. Now, you can kind of see the work that I did. I took each part, I set it equal to 0. If you got something different, a really easy way that we can check our solutions every time is by substituting in these terms for those values. So I do them separately. I have that z minus, or instead of a z here, I've got a z minus 4, but I want z to be 4. So 4 minus 4 times 4 minus 6. Does that equal 0? Well, this is 0 times negative 2, and that equals 0, right? And I can check both of those as simple as that. Now, if for some reason it doesn't equal 0, then I know that I don't have the right solutions, and I need to double check my work. Now, let's take a look at a problem that's a little bit harder. Here we've been taking the product of two numbers. I can do this with the product of as many numbers as I want. Here I have 7 different polynomials that I'm multiplying. So guess what that means? For every polynomial, I have a unique answer. So that means x is going to equal 7 different numbers here. And notice how in each of these cases, we have each polynomial here, and each one looks a little bit different. So I want to set each polynomial equal to 0 and solve for it. So I've got all 7 of my polynomials here. So this first one I would say is x equals 0. This next one would become a 4x minus 11 equals 0. We'd get a 3x plus 7 equals 0, et cetera, et cetera. Now I want you to pause this video, finish finding the solutions here, and then check with my video to see if you have that same thing. So go ahead and pause the video now and come back and see if we have the same solution. Okay, hopefully you've tried this problem on your own. Now you can see I have 7 individual parts here, 7 polynomials that I'm multiplying. And when I find the solution to this full equation here of factored form, notice how I have 7 solutions here. Each polynomial that I'm multiplying will have a unique solution. The only time when it won't have a unique solution is if 2 of those polynomials are exactly the same. And we'll take a look at one of those. So here in this case, I got all 7 of my solutions. Notice how some of these were like a 2x minus 9 or 4x plus 29. This required me to do a 2-step solution, both adding and then dividing. So our goal here every time when we're finding that solution is we need to get x all by itself. And that's what we want to do. So regardless of how many polynomials we multiply, we can always find the number of solutions here. Now, taking a look at a unique example, sometimes we'll end up with problems that look like this. Now remember, x plus 4 squared is the same as x plus 4 times x plus 4. So if I set both of those parts equal to 0, I'd get x plus 4 equals 0 and x plus 4 equals 0. Now notice how those are the same equation. So what I end up with is the same result, right? I end up with x equals negative 4 and x equals negative 4. Now notice how I have the same solution here. These are not unique. They're the same solution. There's only one answer here that'll give me a 0, and that's going to be when x equals negative 4. So if 2 of the polynomials when we are multiplying are the same, exactly the same x value, the same number, then we're only going to have one solution for each of those polynomials, and it's going to be whatever that is. In this case, it's a -4. So that is how we would solve a polynomial equation when it's in factored form. Now I want you to check out this next video. In the next video, we're going to be talking about how when we're given an equation that might be something like this, how we can figure out the solution to that one, right? This is not in factored form. So we're going to have to talk about how to factor this and how to solve it. So take a look at the next video of how we're going to do that.